And then go to the second one is if you have already done a survey work in field, first option maybe your data is based on a paperwork. First, you may need to scan into digital data like this one, a bunch of paperwork, and then you need to scan it and into maybe it's a JPEG or TIFF file. And because it is scan files, so it might not including a correct coordinate. So the first step you need to check is given the picture a right coordinate, and then you may continue to do some editing work. So this is the first concept I will introduce in this part. I would say the workflow one is maybe you complete a survey in work, but it's based on a paperwork. And then you need to scan it and transfer into digital data like TIFF or JPEG, and given a data with the correct coordinate. The function or the tools we use here is called Georeferencing Tool directly in our SuperGIS Data. And after given the data with correct coordinate, we can start to digitize the work to do some editing on our GIS data. And the tool we are going to demo and use in this workflow is called COGO. It's more related to the precise mapping. For example, the first step is how to give a correct coordinate for a raster data. Like the concept is that if you are going to give the raster data a correct precision, you can use the rotate and shift or even scale function in our georeferencing tool. Like this one, the raster data is not located in the correct position. After doing the rectify or georeferencing, we can put it into a correct location. So in our georeferencing tool, we have improved a lot function. For example, we provide the rotate, shift, or scale, and flip function. You can choose from flip horizontal or vertical directly. And we also support for auto adjust. It means that once you add some corresponding point, it will adjust to the location automatically, directly. And then we can also to do the reset transformation and to check the control point list. And remember, it's important that before you do the rectify, you need at least 4 pairs of control points. And then it can start to calculate and to do the rectify. So now, after the step to start to do the georeferencing is like this one. The left picture here shows raster data with wrong coordinate, and the right picture shows here is the vector data with correct coordinate. So you need to add the control point in pairs, like add the first point in here first, and then to add another one to the corresponding location here, and add the second pairs, and then go on at least 4 pairs, and then start to do the georeferencing, and well, given the correct coordinate on the raster data. So once we finish the georeferencing, we can start to do some precise mapping, like this one. The picture shows in the right hand side here. The details like the direction and the distance all shows in the raster data. That because we can base on our survey work, including the details like this one, and then we can use our COGO function to do some precise mapping to start to digitize the GIS data. For example, the tools I'm going to introduce today is there are 2, but previously, we have two toolbars for precise mapping. One is called Advanced Editor, and one is COGO. And in this scenario, I'm going to focus on the COGO part. For example, you can use the traverse function to create the next vertex with specified direction and distance. For this figure, for example, this is the start point. We can give a direction and a distance to add another vertex here, and it will become a line. And to add another vertex by given the direction and the distance, it will become a line feature with a precise mapping. And we provide two methods. One is direction distance, another one is angle distance. So this is how you can work with our traverse function. And another function I will introduce is the offset line. It is useful to create a parallel line by input the offset and the length. For example, the original line feature is the yellow one. If I would like to create another parallel line, but I might need to a little bit change for the offset from 50, 50, and the final one is 30 and 20. I can use the offset line to specify for the distance and to specify for the offset to create a different segment. So this is how you can create a parallel line by given the offset and the distance. So this is the offset line function. Okay, now it's come to the demo time for the first workflow. Let me recall for everyone that the first procedure we are going to do is to do the georeferencing for the raster data that is based on the round coordinate system. So let me move to the demo part first. Okay.
I have a quick question. What is COGO presenting?
COGO presenting, it means that coordinate geometry. It means that your geometry with a correct coordinate. So you might use our COGO function to do some precise mapping.
Alright, so COGO comes from coordinate geometry.
Yes.
Okay, thank you.
Okay. Again, I launched the SuperGIS Data version, the latest version 3.2, and then likewise, you can use this add layer icon to add layers. Also, you can use the drag and drop function like this one, drag the T file directly onto the SuperGIS Data. It will launch. Okay, this is the raster data that conducted in field, and then it is with the round coordinate. So now the first procedure that I would like to continue is I'm going to give the correct coordinate on the raster data. So first I need to find a reference like this vector data. Allow me to add the data in as well here. Okay, now I got two layers. One is the raster data with round coordinate, and another one is for reference. So I'm going to right click to call out the Georeferencing Tool, and then to select the target. It means that select the raster data that I would like to do the georeferencing. This is the survey map. And then the next step is going to add control points. Remember, at least 4 pairs. So I'm going to add the first pairs based on this corner. While you are doing adding the control point, normally we will suggest to add the cross section like this one. And once we add one control point on the round raster data, now we need to go to the reference data we can right click on this one to zoom to active layers. It will directly lead us to the map extent of the layers. And then we can use the zooming function to zoom to the area like this one. This should be located here. So let me add the control point in the corresponding position like this one. You will find it will automatically adjust because the default setting is auto adjust. So it's very convenient for users to adjust. It will help users to display the data more easily because it will change the position to nearby. Okay, so let me add another control point, maybe add this one, the angle here, and then to find the corresponding place here is here. So we can use the check and uncheck to display or make it invisible here. So now I'm going to adding the third pairs, maybe is located here. And then go to the reference data, add the third point as well. And then to find the fourth one, maybe I add another one here. And go to the reference data as well and do it again to add the control point again. And now you will see after 4 pairs control point, there will be a link. And then we are allowed to do the rectify to output the file as a raster data. We can output as a SGR format or JPEG or TIFF. So this is the result. Okay. And then after doing the georeferencing, we can start to do some editing, to do some digitized work. Allow me to adjust a little bit about the layer sequence. We can long press and adjust the sequence, and then the line features there will be upper. And allow me to uncheck this one. So we can now start to create GIS data based on the information listed in here, like this one, by our COGO function traverse. For example, because the information shows here, it is for the line, the road here, the road. So the road is based on the line feature layer. So I'm going to create a whole new feature layer. And how to do that is just simple. Just right click on this one to new feature layer. And you can choose the layer type based on geo file or shapefile and choose the type because the road is based on line. So let me choose this one and choose the coordinate because this fieldwork is conducted in Taiwan. So we just choose the one we normally used, the projected coordinate system. Okay. So once it's created, we can start to enter the editing mode. Just one click on this one and to select the target line feature layer, and then to call out the COGO toolbar, this one. And the traverse function is located here. And the first step we need to decide is the start point. We can use this icon and one click on map to loading the coordinate, and then start to use the plus sign to add another vertex. For example, I would like to use the direction distance type. For example, this is for the direction is about 337 degrees, and the distance is about 338. and then to finish, and then we'll add another vertex right here, and I can add another vertex according to the second information, like 337 degree again, and distance now is 51. Okay, just finished, and we'll continue to add another vertex. Once you finish, just click on this one, and you will create a line feature layer based on the detailed information. This is precise mapping. And allow me to adjust a little bit. For the symbology, you just need to double click on this one, and then you can choose the symbology that you would like to apply. And the second function that I will introduce is if you would like to create a parallel line based on this one, the function you will need is the offset line. You'll see this is unable to use now because you need to select the target first. For example, I would like to, based on this line feature layer, to have an offset line. So I need to choose this one and then apply this function. And then to use this plus sign again to give a distance along, it means from the start point, how to set the distance from the start point. For example, I may choose set for 50. The unit is based on the display unit. You will see here is in meters, and the offset, it means, let me set about 30 meters. It means that it will create another vertex 30 meters parallel with this one, but you can choose for the side, maybe it's for left or right. So I will just choose for left, and to finish, you'll see this is the new vertex, and another one allow me to add another vertex. Maybe this time I would like to expand my distance about 100 meters, but now the distance alone, it means that difference from the start points. So if I would like to expand another 100 meters, I will need to type 150 plus this one, and then to set for the offset, and we'll finish to create another vertex and connect together, become a line feature layer. So once we just finish, we can just stop editing to save change. So this is how you can do the georeferencing and do some precise mapping based on the detailed information for your field work. So